Hey everyone, welcome to this Toppr Live class session, and sorry for being a little late, but we just wanted to give you the best possible streaming we could. So, well guys, in this Toppr Live class today we are going to discuss some questions on permutations and combinations. So we've been seeing that our permutations and combinations classes had quite a huge boost, and but at the same time the students were asking that if there were problem solving included, it would have been very great. So just for you guys, just for the demands, just for fulfilling the demands of the students, here we are with some questions on permutations and combinations, right from the very basic level to some some real tough questions. So we'll be solving close to five questions in this class, and we'll start with like some very basic problems in which we'll be discussing questions on permutations normally, and eventually we'll move on to arrangements and more cases, and at the same time application of multiple concepts as well. So the idea is to give you a look into how these questions are asked in any sort of examinations, and at the same time permutations and combinations, it's not really a tough topic at all. The questions are pretty straightforward as observed in the past 3 years JEE papers, so you don't really have to worry much about it. It's just that it's just a game of numbers. All you have to do is understand the statements, play the game of the numbers, and win it. Cool. So guys, without wasting any time, we'll start the class, but before that I'll do my usual. So this Toppr Live classes on mathematics is not the only class which Toppr is doing. We have had a numerous live classes on various other subjects as well in the past, and we are going to continuing to do so in the future as well. So what you can do is, if you want to be a part of these live classes, you can go to our YouTube channel and subscribe to us, and at the same time you can also like us on Facebook, follow us on Instagram and Twitter. Basically just keep us in your social media circle, and we'll inform you, will update you regarding these live classes without fail. And if there are some commerce friends of yours, from friends who are from the commerce stream, then you can also tell them that we had a live classes marathon, not exactly a marathon I would say, but yeah, a series of live classes for CA foundation practitioners as well. So they can go through those classes as well for their own good, and I'm pretty sure they'll take something positive from it, which will help in the preparation of their examination, and will be very happy to provide such assistance. So guys, without wasting time, let's take on our first question for the day. This question, it's actually a very simple question. The question is, the letters of the word random are arranged in all possible ways. The number of arrangements in which there are two letters between R and D is. Now guys, these kinds of questions are actually very common in any sort of examination. It's just that the kind of constraint which they'll be giving is different from which I'll be taking in here. In this particular question, you can see that the constraint is that the number of arrangements, we have to talk about the arrangements in which there are two letters between R and D. So clearly you can say that if R is here, then D would be here, and in between there will be two places empty. But at the same time, we can also have a possibility in which this D is here and this R is here, with two possibilities or two places in between. So we'll start from the very basic thing. We'll start from the word which is given to us, which is random, and random, you all can see, is a six lettered word. So 1 2 3 4 5 and 6. Now let's consider case by case, that in which scenarios we can put R and D in such a way that there are two letters in between them. So we've already discussed one case over here. I can see that there is R and D and there are two places in between, and then there are two places which are trailing. The next case, which would be this case, in this you can say that there is R and D over here and two places are empty like this. And then we can also say that there is another case in which R and D are here and the two places are like this. So this clearly tells you that there are three possible ways of arranging R and D in this particular scenario, in a scenario in which there will be two letters between them. But hold on, do you think these are the only three possible ways? Well, you could see that there is one way which we have mentioned here as well, in which D is before and R is trailing D. So in such cases as well, we will consider the constraint satisfied, which is why you can say that a similar thing will be observed in these kinds of arrangements as well. Some brilliant minds at work while the internet continues to, well, sabotage our entire thingy. Anyway, so I have like another possible arrangement right over here in which D will be here and R will be here. So basically the idea is that like R and D have two letters in between them doesn't mean that R and D cannot interchange their positions. So in this particular case, the total number of arrangements that we actually want to talk about, it is actually equal to 2 times. Now this 2 is because of dr and rd. So this 2 is because of this into 3. This 3 basically tells about the possibilities which you can see that where or which all positions these R and D can occupy. So it can either occupy a first, fourth, or second, fifth, or third, sixth. So possibilities. And finally the arrangements, and for the arrangements all we have to do is just make sure that whatever the rest places are, they are filled in the normal way. And how many empty places do we have? We have 1, 2, 3 and 4 empty places. Now we know that there are 4 letters and we have 4 places to fill. So how many possibilities or how many ways can we do that? We can do it in 4 factorial ways. So basically the answer would be 2 times 3 times 4 factorial, or you can say 2 times 3 times 24, which will ultimately give you 144 ways. So this, guys, is the answer to your question. Your answer is option C. The correct answer is option C. There are 144 arrangements in which there will be 2 letters between R and D. Now guys, this is again, as I said, one sort of or one type of constraint. There could be different types of constraint. At the same time, there could be numbers instead of these letters over here, and they might ask you that okay, tell me the arrangements in which the numbers are forming an even sequence, that is the numbers are even numbers. So in such cases you will take the last digit to be even, which means it could be either 0, 2, 4, 6, 8 or whatever the digits given in the question. Out of those, the even digits, only those digits could be placed at that last position. So while solving such questions, guys, the important thing is to first satisfy the constraint and then move ahead with the further arrangements. Okay, first satisfy the constraint, fulfill the constraint whatever the question is asking for, and then move on and solve the question. Okay, so I believe this question is pretty much clear to you now. Now we'll be moving on to our second question, and our second question is based on arrangements. Okay, so now that you've seen the question, I'm going to just shorten it a bit. So the second question over here, it says the number of ways in which 6 Telugu, 4 Hindi and 3 English books be placed in a row on a shelf, so that the books of the same subject should remain together. This, guys, is another very interesting question. And this is interesting because in this we get to make units. And why will we be making units? So let me just give you a heads up. Just let me give you an idea of how to solve these kinds of questions. So you could see that there are 6 Telugu books. So what I can say that Telugu 1, Telugu 2, Telugu 3, Telugu 4, Telugu 5 and Telugu 6. ये हमारे पास में 6 तेलुगु बुक्स हैं. ठीक है, अब हमारे पास में 4 हिंदी बुक्स भी है. तो हिंदी 1, हिंदी 2, हिंदी 3, हिंदी 4 and finally I have 3 English books. So English 1, English 2 and English 3. अब हमें इन बुक्स को इस तरह से अरेंज करना है एक शेल्फ पे कि जो सेम सब्जेक्ट की बुक्स हो वो एक साथ आए. एक साथ आने का क्या मतलब है यार, कि अब ये T6 और H1 जो है ये आपस में इंटरचेंज नहीं हो सकते। T1 को या T6 को बची हुई तेलुगु जो बुक्स है उन्हीं के साथ रहना पड़ेगा। दे कैन बी they can be like just right next to each other if all the Telugu books are still together, but otherwise this Hindi book or English book can't really get in between any of these Telugu books. They have to be separated or they have to remain different on a different position other than the Telugu books. So in such cases what we do, we form units. तो यहाँ पे मैं लिखूंगा यूनिट्स फॉर्म कर दो। तो जिन लोगों को साथ में रखना है उनको एक यूनिट मान लो। तो भाई सीधी सी बात है, मुझे सारी तेलुगु बुक्स को एक साथ रखना है, तो मेरी ये यूनिट 1 हो गई, ठीक है। इसके बाद में मेरी हिंदी बुक्स जो है वो मुझे साथ में रखनी है, तो ये मेरी यूनिट 2 हो गई। और फाइनली मेरे को मेरी इंग्लिश बुक साथ में रखनी है, तो ये मेरी यूनिट 3 हो गई। इन 3 यूनिट्स के अलावा क्या कोई और यूनिट है हमारे पास? नहीं है। तो चलिए काम करते हैं, नंबर ऑफ अरेंजमेंट्स की बात करते हैं। नंबर ऑफ अरेंजमेंट्स हो जाएंगे 3, है ना। और अरे यार 3 नहीं, सॉरी 3 फैक्टोरियल, बिकॉज 3 है तो ऑब्वियसली इट्स 1 3 2 1 2 3 2 3 1 2 1 3 3 1 2 3 2 1, like 6 possible ways, so 3 factorial ways. But important thing is that there is no such answer as 3 factorial. There are a lot of different numbers which are multiplied with these 3 factorial, or if there is 3 factorial, it is either in numerator, denominator and various things. So from this thing, that from this number of arrangements, there is one thing that's for sure, that C और D हमारे आंसर नहीं हो सकते, because C और D में जो हमारा 3 factorial है वो न्यूमरेटर होने की बजाय डिनोमिनेटर में है, और सिंस वो डिनोमिनेटर में है तो उसे न्यूमरेटर में क्रिएट करना विल बी वेरी डिफिकल्ट। तो इस वजह से हम C और D को यहाँ पे रिमूव कर सकते हैं। अब बात करते हैं अगले की। अब अगले को अगर आप देखें तो उसमें आपको दिखेगा कि 2 ऑप्शन है अब हमारे पास में। एक है 6 फैक्टोरियल टाइम्स 4 फैक्टोरियल टाइम्स 3 फैक्टोरियल, और एक है 3 फैक्टोरियल टाइम्स 6 फैक्टोरियल टाइम्स 4 फैक्टोरियल टाइम्स 3 फैक्टोरियल। ओके, बहुत सारे वर्ड्स हैं, बहुत सारे नंबर्स हैं, बट ये नंबर्स आखिर क्यों आए हैं? वेल, ये नंबर्स इस वजह से आए हैं क्योंकि ये तो हमें पता चल गया कि हम यूनिट्स फॉर्म कर सकते हैं, बट इसका मतलब ये थोड़ी है कि जो यूनिट्स फॉर्म हुई हैं वो आपस में नहीं अरेंज हो सकती। यानी कि तेलुगु बुक्स आपस में अरेंज नहीं हो सकती क्या? मतलब ऑब्वियसली हो सकती है। तेलुगु बुक्स में किसको मना किया है कि भाई T1 जो है वो T4 के बाद नहीं आ सकता, या T5 जो है वो T2 के पास नहीं जा सकता। देयर आर डिफरेंट पॉसिबल वेज टू अरेंज द तेलुगु बुक्स इन बिटवीन और अमंगस्ट ईच अदर। सो इस वजह से मैं क्या करूँगा, यहाँ पे मैं देख सकता हूँ देयर आर 6 तेलुगु बुक्स, राइट। So because of this, we'll multiply with a 6 factorial, because 6 things to be arranged in 6 different positions, so 6 factorial ways. Then you will multiply the same with 4 factorial, because Hindi books can also be arranged amongst themselves, and similarly the English books can also be arranged amongst themselves. So the number of arrangements would be 3 factorial times 6 factorial times 4 factorial times 3 factorial, and hence the correct answer guys is option B. Okay, so ध्यान रखिएगा, अगर आपको कुछ चीज़ों को एक साथ रखना है हमेशा, तो उन चीज़ों को आप एक यूनिट मान लीजिए, उन्हें मान लीजिए आप एक यूनिट, और फिर उस तरह से आप अपना जो क्वेश्चन है वो सॉल्व कीजिए। अगर आपने एक यूनिट नहीं माना है तो उस क्वेश्चन को करना काफ़ी डिफिकल्ट हो जाएगा, बिकॉज क्योंकि चीज़ें को साथ में रखना है, देन इट विल नॉट रियली बी पॉसिबल टू हैव इट इन लाइक यू नो और सॉल्व इट बेसिकली इन अ वे जिसमें वो साथ भी रह सके और हमारे कंस्ट्रेंट जो हैं वो भी फुलफिल हो जाए। इट विल बिकम वेरी डिफिकल्ट अगर आप इनको यूनिट के अलावा किसी और मेथड से करने की कोशिश करते हो। तो चलिए, मैं समझ सकता हूँ कि ये क्वेश्चन शायद थोड़ा सा डिफिकल्ट रहा होगा, तो हम इसी की तरह का एक क्वेश्चन और करेंगे जिससे कि आपको आइडिया लगेगा कि ओके, इन क्वेश्चंस को मुझे इस तरह से करना है, ठीक है। तो चलिए अब एक काम करते हैं, क्वेश्चन 2 को यहाँ से हटाते हैं और क्वेश्चन 3 देखते हैं। ये क्वेश्चन 3 बिल्कुल क्वेश्चन 2 जैसा, इनफैक्ट ये उससे ज़्यादा सिंपल है। Why I have picked it as my third question is because this particular question was asked in one of the JEE exams. So the whole point of putting this question here is to make you understand that in JEE, the questions are actually quite basics from permutations and combinations. All we need to do is make sure that is to understand the question and then do our action or plan our course of action accordingly asked. So let's see this question. In a library, there are M books of mathematics and N books of natural science. They can be placed on a shelf in, well, 1209600, or I can say 12,09,600 ways, so that the books of the same subject are not separated. If m is greater than equal to m, now this is a very important condition guys, m is greater than equal to n, यानी कि m की जो वैल्यू है वो n से बड़ी होनी चाहिए, then what can be a possible value of m? So guys, as I said, let's say that we have books mathematics की, तो हम उसे एक काम करते हैं, नाम दे देते हैं m1, m2, m3 and so on, m small m. The small m basically is the number of mathematics books which we have, and we'll consider it as 1 unit, right? And similarly, I have n books of natural science, so I'll put science S1, S2, S3 and so on until Sn. Now guys, these m books can arrange themselves in m factorial ways. These n books can be arranged in n factorial ways. Why? Because इनमें आपस में अरेंजमेंट होना पॉसिबल है. ये कहीं नहीं लिखा गया है कि इन बुक्स को आपस में अरेंज नहीं किया जा सकता. इन बुक्स को आपस में अरेंज किया जा सकता है प्रोवाइडेड द बुक्स ऑफ द सेम सब्जेक्ट आर नेवर सेपरेटेड. ओके, ये जो बुक्स आप ले रहे हैं सेम सब्जेक्ट की, दीज शुड नॉट बी सेपरेटेड फ्रॉम ईच अदर. यानी मैथ की बुक सिर्फ मैथ के साथ रहेगी, साइंस की बुक सिर्फ साइंस के साथ रहेगी. ओके, सो ये आ गए हमारे पास में m factorial into n factorial ways, but at the same time these can interchange positions, right? And since these can interchange position, we have another 2 factorial over here. So the number of arrangements in this particular case, it will be very simple. It will be m factorial into n factorial into 2 factorial. But guys, don't you think this value is already given to us? We've already been told that this m factorial into n factorial into 2 factorial is equal to 1209600. So what we'll do, we'll simply divide this by 2 and that will give us m factorial into n factorial as, well, this will become 604800. Okay, so we have 604800. Now we have to find out the value of m for which this will be possible, provided that m is greater than equal to n. Now from what I see is that I have 4 options. What I'm going to do, I'm going to put each option here once and see that am I getting a proper factorial value for the n factorial as well. Upon doing that, what you'll observe is that for 6 factorial, the answer would not really come. So if you do it for 6 factorial, n factorial will be equal to 604800 divided by 720. Now when you will solve it, the answer that you are going to get, tell me what will it be? 604800 divided by 720. Hurry up guys, I'm waiting for the answers in the comments. 604800 divided by 720. Yes, that is correct. The answer would be 840. Thank you so much. So we have 840, but we know that 840 is not a factorial value. So if n factorial is equal to 840, then this is not happening, not possible. Since it is not possible, so we'll have to do something else. So this first option can't really be our answer. However, when you'll put for the second option, you'll see that n factorial is actually equal to 604800 divided by 5040, and this is going to give you 120. We know that n factorial is equal to 120, which implies that n is equal to 5, and this basically gives us the number of books of number of m and n over here. This m is equal to 7. 7 is going to be the correct answer, because for this we are getting a value of n which is satisfying the factorial notation condition. So if you check it for 8 and 9 as well, you'll see that the answers are not really matching any factorial value. So which is why the answer will be m is equal to 7. That is, if it is m is equal to 7, only in that case, well, we can prepare a shelf in 12,09,600 ways so that these books are not separated from each other. So this, guys, brings us to the end of our third question and another important concept. Now moving on, let's move on to our fourth question, and this question is a little interesting one, I would say. The reason I'm saying that this question is interesting is because it has lots of values. So let's just look at the question. If A denotes the number of permutations of x plus 2 things taken all at a time. So what is A? A basically is permutations of x plus 2 different things taken all at a time. We know that x plus 2p x plus 2 is going to be x plus 2 factorial. So this is x plus 2 factorial. We've got the value of A. Now let's try to find out the value of B. This B is actually equal to the number of permutation of x things taken 11 at a time. So I can say that this is p x p 11, or you can say x factorial upon x minus 11 factorial, right? And finally we have C, which is the number of permutations of x minus 11 things taken all at a time. So it is going to be x minus 11 p x minus 11, or you can say that this is x minus 11 factorial, right? Now what we have to do is, these values basically are taken in such a way, these values of A, B, C are taken in such a way that A, which is given to us, this A is actually equal to 182 times B times C. So we'll have to simplify it first. This is x plus 2 factorial equaling 182 times B, which is x factorial upon x minus 11 factorial into x minus 11 factorial. You can cancel out this x minus 11 factorial with this x minus 11 factorial, and ultimately what you're going to get is this x factorial also will further simplify. It will be cancelled out and it will give us x plus 2 times x plus 1 times x factorial, and these two x factorials will be cancelled. So ultimately we'll be left with x plus 2 times x plus 1. Now if your math is great, then you will find out that the values that we are talking about is actually 14 times 13 or minus 14 times minus 13. So there are two particular values possible, but then again, since we are talking about things, negative values can't really happen. So x is going to be equal to 12. X will be equal to 12. This x is equal to 12 basically is the value of x. And how did I get it? Well, you can directly write this as 14 times 13, or you can even solve it by the method of quadratic equations. You can solve it by the factorization method by simplifying the left hand side first and then taking 182 towards the left hand side again. Or you can use trial and error method, because, well, from the four options given, the only possible value or only possible scenario in which I can have a value of x is when x is equal to 12. So when x is equal to 12, it will become 14 times 13, which will give us the answer as 182. Right, guys? So this basically tells us that the answer to our fourth question is option B. And now, guys, for the last question of the day, and this has to be very big because it's the last question. And here I present to you my masterpiece, which I've saved till for the end. This particular question has the application of both permutations and trigonometry, permutations, combinations and trigonometry. So let's just look at the question once. If m is the value of x for which sine inverse 1 plus x square upon 2x is greater than 0 and k be the digit of the tens place in the number summation 1 r is going from 1 to 2000 r factorial, then which of the following is true? Well, sounds like a pretty scary question. Well, of course, if I'm looking at it at first, then yes, I'll be scared as hell. But Eventually, if you'll just connect the dots, which the question is asking you to do, you'll see that the question is actually very simple. So let's just start with the very simple thing first by decreasing the size of the question. So this basically is our question, which is given over here. Let me just reposition myself. So this is our question over here. Now, just look at the question. If m is the value of x for which sine inverse 1 plus x square by 2x. So it is asking us to do sine inverse 1 plus x square by 2x as greater than 0. So this is greater than 0. Now, for anything in sine inverse to be greater than 0, we know that the value of, or the range of sine inverse function is minus pi by 2 to pi by 2, right? And it is from minus pi by 2 to 0 for values less than 0. So for values greater than 0, it is of course going to be a positive value. And if it is a positive value, then I can say that 1 plus x square upon 2x has to be positive as well. Now, again, 1 plus x square upon 2x is greater than 0. We know that the right hand side, the numerator, sorry, the left hand side, the numerator, it is always positive. And since it is always positive, so for this entire thing to be positive, x has to be positive. So x will be greater than 0. I repeat, 1 plus x square is a positive value. And if you want entire 1 plus x square upon 2x to be positive, then for this x has to be greater than 0, okay? And if x is greater than 0, then I can say that in such cases 1 plus x square upon 2 is greater than equal to 0, as it is is greater than equal to x, because it is the rule of am greater than equal to gm. So we've used the simple rule of am greater than equal to gm here. I have first proved that all these values of x is positive, so that actually I can send this x on the other side. And this basically is giving us 1 plus x square upon 2x, or basically you can say 1 plus x square upon 2 is greater than equal to x. Now, in other ways, I can also say that 1 plus x square upon 2x has to be less than equal to 1, because for this, it has to be this sine function 1 plus x square upon 2x has to be less than equal to 1, because it is in sine inverse, and we know that sine of inverse, basically the domain in which this 1 plus x square upon 2x can lie is from minus 1 to 1, but since it is positive, so it will be from 0 to 1, but 1 is the limit. It cannot be greater than 1, which is why I can say that 1 plus x square upon 2x is less than equal to 1, and when you simplify this, you are going to get x minus 1 the whole square as less than equal to 0. Right? So x minus 1 the whole square is less than equal to 0, which clearly imply that x minus 1 or you can say x is equal to 1 is the only solution possible, because it has to be less than equal to 0 as well. At the same time, we have to also make sure that this entire thing is positive as well. So for all these things, x is equal to 1 is the only solution. Now, if this is the only solution, if x is equal to 1 is the only possible value, then I can say that my value of m is also equal to 1, right? And if the value of m is equal to 1, like if m is the value of x for which sine inverse this is greater than 0, so I can clearly see that this m is actually equal to 1. So now all we have to do is find out the sum of the series. Summation r is going from 1 to 2000 r factorial. Now this particular value, well, the value of this r, it's simply going to be 1, 2, 3 and so on up till 2000 factorial only. So we are just going to go about that, but at the same time all the terms starting with or starting from 10 factorial will have at least 2 zeros at the end. So what I'm trying to say here is that this particular value will be 1 factorial plus 2 factorial plus 3 factorial and so on up until 2000 factorial, right? The point is that after 10 factorial, if I take any value or even from from 10 factorial, then there are at least 2 zeros, because value of 10 factorial is equal to 3628800. Like, this is what I closely remember. It could be wrong, it could be correct, but this is for sure that there are 2 zeros at the end, which means that we have to make sure that there are that we don't really take such some terms which has 2 zeros, because we don't really need it, which is why this entire thing summation r will become summation r from 1 to 9 r factorial, which will be equal to 1 factorial plus 2 factorial plus 3 factorial and so on up until 9 factorial, right? Now since we have to find the digit of the tens place in the number, well, since there are 2 zeros, so we haven't really considered anything from 10 factorial onwards. So you can say that this will be 1 plus 2 plus 6 plus 24 plus 120 plus 5040, or basically since I need the only tens place things, so I'll only take 20, not even 120. For 7 factorial it is 40, for 8 factorial it is 20, for 9 factorial it is 80. This basically will give us the units place and the tens place. When you add them up, 3, 9, 33, 53, 93, 113 and 80. I think the addition part would have been like, so let me just, okay, yeah, we have forgotten 6 factorial, which is why I've missed 120. So when you'll add this is for 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, 7 factorial, 8 factorial, 9 factorial and 6 factorial. When you'll add them up, this will become 213, which clearly imply that the value of k is equal to 1, because this is the 10th place. Now this k is equal to 1, this m is equal to 1. Can you tell me the relation which will be established between m and k? Well, that is correct. We can clearly imply that m is in fact equal to k, which is why option C is the correct answer, guys, right? So you can see that questions like these, are like, pretty simple, and just have some like, sort of rocket science, and it just takes some rocket science in understanding them. Like, if you are aware with the flow of the question or aware of the flow of the question, I'm pretty sure there's no stopping in questions of permutations and combinations for anyone. Okay. So guys, with this we have come to the end of this Toppr live classes. I think there is something which my team is going to trying to tell me by ishare, and the ishare basically says that in the next week we'll be continuing with the classes with circles. So the classes of circles which which could not happen this week, it will happen again, or it will resume from next week onwards. So make sure you guys are present for them, for that class as well, along with the other classes for physics, chemistry and biology. Of course, if you are math guys, then biology is not required, but that doesn't mean if you are medical guy, then biology is not required. It's of course required, right? And for some of you, if it is PCMB, then both of them are required. In any case, guys, enough of digressing. I would say, again, these classes I believe are an excellent source of knowledge, and best part, free. Don't you think? I mean, these are sessions in which you are getting mentored, or you can ask your doubts or get your queries resolved by experts for free. You should actually turn the crowd up and up the ante, and ultimately all you're going to get are some excellent sessions which will help in improving your knowledge. So guys, for sessions like these, if you want to keep joining them, if you want to be updated about them, to make sure that you don't forget to subscribe to our YouTube channel, like us on Facebook, follow us on Instagram, Twitter, keep us in your social media circle, and we are there to deliver, we are there to help. So until next time guys, bye bye, take care, all the best.